All right, let's say that I've got a book here, and on top of this book I have a coin that is placed right here. And we know that if I do that and I start to take the cover of the book and I start to bring it further upwards like this, or as I start to increase the angle here, that coin will not at first will not start to slide down this cover of this book until I reach a certain angle. Now, we know from the previous discussions also that there are forces acting on this coin in different directions, and so if we remember, we have a force that is this way, that is parallel, a parallel force to the cover, and then we also have a force that is perpendicular. Let's pretend that line is straight. Force that is perpendicular to the surface. And these are, both these forces here, the parallel force and the perpendicular force, are components of this force here that acts towards the center of the earth, the force of gravity, or in other words, the weight of the object, which is just the mass of the coin times the acceleration due to gravity. So this and this are components of this force here. We also learned that we can figure out in the last video the normal force, which is basically opposite of whatever my perpendicular force is. And we also learned how to figure out what the acceleration is as this coin starts to move down the book. Now, let's say that as we increase the angle of this cover of this book, that the coin doesn't start to fall, because we know that there is this other force that we haven't talked about yet. There's a force pushing back against it this way, pushing back against the motion of the coin this way, which is the force of friction. And so as we increase the angle, there's a force of friction pushing back this way on the coin, which is keeping it from sliding down this way. Now at a certain point, though, I'm going to keep lifting up this book, and at a certain point, the force, the parallel force this way, is going to be great enough. Because think about it, as I increase this angle this way, the more closely this parallel force gets to being the weight, right? So if I keep increasing the angle this way, this parallel force gets closer and closer to being equal to this weight here, basically. And so at a certain point, at a certain angle, this parallel force here is going to overcome this force of friction being provided by the book, and the coin will then slide down. Let's say that a question asks us that we know that the angle at which this coin first overcomes that static friction is 38 degrees. So let's say we know that it's 38 degrees is when this first overcomes that static friction, and the question maybe asks, well then what is the coefficient of static friction? What is the coefficient of static friction? Because remember, we learned about this a couple of units ago, that static friction is different than sliding friction. So static friction is what's keeping it from moving, but as soon as it starts to move and slide, then we are thinking about sliding friction, which is a little bit less than static friction. So we want to figure out what is the coefficient of static friction here that's keeping the coin from moving, because as soon as we hit 38 degrees as we open this book, then it starts to move, so we know that we've overcome static friction. So how would we go about figuring that out? Well, let's think about it like this. We know that in order to first overcome that force of static friction, that means this force going in this direction, must be equal to that force of friction here. So in order to overcome that, this parallel force here has to be equal to this force of friction. Now I'm going to need to know what the force of friction is in order to figure out the coefficient, because we also have to remember that the force of friction is equal to mu, which, remember, that's the coefficient of friction there, times the normal force. So there's my equation for the coefficient of friction. So I need to figure out normal force, and I need to figure out the force of friction. Well, force of friction, we just said, is going to be this parallel force. The normal force, which remember we learned in the last video, is going perpendicular this way to the surface of the book, which is going to be the opposite of this perpendicular force pulling down. So what I need to do is I need to first figure out what is this. Because if I can figure out what the weight of the book, or what the weight of the coin is, I should say, what the weight of the coin is, then I should be able to, or the force of gravity on the coin, then I should be able to figure out this, and I should be able to figure out this as well. But here's the thing. The problem doesn't give me, actually doesn't tell me what the mass of the coin is, and it doesn't tell me what the force of gravity on the coin is, so I actually don't know the weight. Let's see if we can figure it out without knowing what those are. Well, first of all, let's think about it like this. We know that the perpendicular force, let's say, is equal to what? Since we know that this, right, we're going to take this force, we're going to bring it down here to make a right triangle here. We know that the perpendicular force is going to be the weight of this, so this side of this triangle basically, times the cosine of the angle. Remember that this angle here is the same as this angle here. So the cosine of 38 degrees. And the parallel force is equal to the weight times the sine of 38 degrees. Okay? So now let's think about it like this. Let's say that I want to figure out the normal force first, right? The normal force. Well, the normal force we know is going to be whatever this perpendicular force is, right? So normal force is going to be equal to whatever the parallel force is, which is equal to the weight times the cosine of 38 degrees. And I can do the same thing for this force of friction. We know that this is going to be equal to this parallel force. So my force of friction is equal to the force that is parallel, which is equal to the weight times the sine of 38 degrees. So for the force of friction now, if we're thinking about it, let's substitute in what we've just figured out here. So force of friction, we just said, is the weight times the sine of 38 degrees, right? So let's plug that in. For my force of friction here, the weight times the sine of 38 degrees is equal to mu. For the normal force, it's going to be the weight times the cosine of 38 degrees. So, if I'm going to figure out mu here, this coefficient of friction, what I have to do is just divide these out, right? So I'm going to divide by W cosine 38 degrees on each side. Whoops, cosine, not sine. Cosine of 38 degrees. And so my equation reads like this. Mu, or the coefficient of friction, is equal to weight times the sine of 38 degrees over weight times the cosine of 38 degrees. And look at this. Weight just cancels out, doesn't it? Because when I divide those two terms, those are going to cancel each other out. And so what I'm left with is the sine of 38 over the cosine of 38, which is going to be the tangent of 38, which equals 0.78. Remember that the coefficient of friction is unitless, so there's no units for this. So my final answer is just 0.78.